Hey there, welcome back. And let's continue to dive into marine protected areas. We had a really neat presentation on Monday, and I was hoping we could flesh that out a little bit more. The topic that is the overall topic of marine protected areas. So a little brief plan here for looking at some definitions and benefits of marine protected areas, different approaches to them, and then also some issues in the management of a marine protected area or multiple ones in general. So according to the IUCN, which I have included, if you're unfamiliar with that acronym, I highly imagine throughout your geography or other major you're bound to hear about them a lot more. But it's the International Union for the Conservation of Nature, leading global body in many different aspects of conservation. So any area of intertidal or subtidal terrain, together with its overlying water and associated flora, fauna, historical and cultural features, so that's a really great point to be included, which has been reserved by law or other effective means to protect all or part of the enclosed environment. So pretty comprehensive there, and some really neat individual features that we could begin to think about a little bit more specifically, or some of the issues around them. Hopefully with some of the concepts or questions that we've been probing throughout the course. But yeah, this notion of the perfect marine protected area, ecologically speaking, this is something that Roberts et al. Talks about. Reserves whose objectives include conservation or fishery functions must have a solid foundation in biology to succeed. A reserve with little biological value will provide few benefits, just as a bank account with little money will yield almost no interest. So really rooting down into, as he says, as they say, the biological value here. And just some notes to continue on this point. Obviously, the design of marine protected areas is a complex issue. Factors to consider include the economic, social, scientific, feasibility, and biological or ecological issues. Here I'm going to talk about, or I'd like to focus on, the biological and ecological issues that need to be, and in parentheses, but realistically are rarely considered when designating a marine reserve. So I hope you'll get a better understanding of how marine communities are maintained over broad scales and how complex they are, which is nothing new to a coastal topic, right? The complexity. We could argue any geographic concept, how we, perhaps even we're pretty keen on adding complexity to it, or taking a complex lens so that we can tease apart the nuances and understand it better, and critique, improve. So just to continue on that notion of the perfect MPA, I mean, it's a bit of a tongue-in-cheek notion, or the idealized, right? We're not trying to say that there is a perfect one, but just to, I don't know about to dream, but to set the bar high here for our discussion. We want to sustain populations within a protected region, right? That's pretty clear. Coverage of all biogeographic regions, including transition regions. And this is really important because it's easier to monitor shifts in species distributions in these transition zones. And we need to allow protected populations to do well enough to help populate areas outside of the protected area. And this slide is a representation of what we mean by that, in terms of, perhaps my picture box is in the way there, but outside of the protected area, here we have our protected habitat protection with some large adult rockfish, perhaps. And this is the unfished reserve, but both the larvae spilling over, but also adult fish into a fished area. All right, demonstrates how the benefit of having a protected reserve, this notion of the spillover effect, how the benefits to the surrounding ecosystem, the overall ecosystem, are more pronounced, are extant in more than just the protected reserve. And this is actually a really amazing benefit of having marine protected areas, conservation areas on land as well. The benefits that they have to the surrounding regions, right? I don't want to say just ecosystem, because we could think of it more broadly as that, but surrounding habitats, surrounding zones, and numerous biologic, ecological benefits from this spillover effect. In this case, also tying in this concept of the recruitment subsidy, how the marine protected area is actually subsidizing the recruitment. So it's a little basic scheme there for you, but some other benefits here of marine protected areas: protection of marine biodiversity, represented ecosystems and special natural features, support the rebuilding of depleted fish stocks, insurance against inadequate management, provision of benchmark sites. Benchmark sites we can think of as setting up a reserve, a marine protected area around or over, so to speak, a particular site that sets the benchmark, is a almost in terms of the keystone species theme, that this particular zone can serve as the benchmark, the model area for the surrounding habitats. So protecting one of those so that we still have those for providing for science, for the overall benefit of the ecosystem. And then, to continue on here, this recognition of cultural links is a huge benefit of a marine protected area. And then, continuing on that thread, provision of opportunities for recreation and education. These are all demonstrated benefits, and to me they speak loudly to how important marine protected areas are, and the opportunity that they provide for more of these sorts of benefits for our world. So do they work? Yes. There's ample empirical evidence to support this. Again, I'm going to try to move this out of the way here. This is a really neat partnership, PISCO, the Partnership for Interdisciplinary Studies of Coastal Oceans, and out of Oregon State University down in Central Oregon, just north of Eugene. Blanking on the city name there. Our Oregon students are going to be laughing at me, but right near Albany. And anyway, though, collaboration between several different universities as well down in California, Stanford, and UC Santa Cruz, UC Santa Barbara. Maybe one of you will spearhead UVic joining this partnership. But yeah, if you check it out online, I included the little logo there. Some phenomenal research being done by the partnership. And so here we have some demonstration of some of this empirical evidence to support that MPAs not only increase biomass, but also number of organisms, size of organisms, and increase biodiversity. So there's an average. I mean, the biomass alone is just staggering for these. So here we have N as the number of reserves. So over 55 reserves that were studied for biomass, you have an average of 446% higher, or percent change, sorry, so an increase in biomass. You know, some of the plots upwards almost of 3,000% change. So it's just phenomenal figures there to comprehend. And I don't know, I get really enthused when conservation projects are demonstrated or are shown, you know, empirical evidence that speak to just this huge benefit provided. And so, you know, to represent here some benefits of increased size of organisms. You have Love et al. Here, way back from 1990, a NOAA technical report. Again, NOAA standing for National Oceanic and Atmospheric Administration. You'll hear about them a lot, as we have earlier in the semester already. So, yeah, this one smaller fish here representing 100,000 young. But so for the as an individual fish is allowed to increase in size, i.e., not getting fished, not getting killed, eaten, or fished and not eaten, you have significantly, exponentially more average of young produced by increasing size of adults. So that's pretty significant as well. Speaks to the huge benefit of having these protected areas. And then as a demonstration of effects outside of reserve boundaries, from Torre Huaceto. Yeah, I guess I'm going with more of a Spanish pronunciation there. If there's any Italian speakers, feel free to lend a hand. But yeah, so a key area to clue in on here is the density number per 100 square meters on upwards of 3.5 kilometers outside of the area boundaries, and you have yeah, higher densities, you know, corresponding to those adjacent areas, and then a kind of bell curve tapering off from there, even outside of these two black dotted lines that the authors put on this graph. Sorry, I don't have the reference there for you, but you know, it's just another example or iteration of these benefits, and, in this case from across the world in Italy, so that's pretty neat. So different approaches then to marine protected areas. We want to kind of distinguish here between two classes or types that are generally talked about: systematic or opportunistic. And for example, in systematic national marine conservation areas, which we'll get to in a little bit, as well as ecologically and biologically significant areas, those being two specific designations here in Canada and elsewhere in the world, but also on the other side of the spectrum, I don't know how many different iterations there are in between, but I imagine there's different ways of combining these. And what we mean by opportunistic is more of special places or species-specific protected areas. We have a couple examples of those later on as well. So to dive into systematic a little bit deeper, we have a representative network. There's supposed to be there we go. A key feature of the systematic approach is representativity. A representative network of MPAs is one that captures examples of different biogeographic subdivisions that reasonably reflect the full range of ecosystems which are present at the scale of network development. There's a big phrase, network development, including the biotic and habitat diversity of those ecosystems. This is from DFO large report in 2012, which I'm going to provide the link there for you. But just to continue on that representativity theme, or explanation rather, I have a little DFO 2012 on my slide on this end. There we go. To conclude, a network is representative. Another key part from this report from the DFO, these three requirements must be met. An accepted biogeographic classification system to guide what such a unit of bioregion are to be represented in a network. An accurate and informative map of the bioregion relative to that classification system, right? So as to guide where the selective areas are so that they represent the intended biogeographical units, all right? Not trying to, converse to not trying to make this very delineated and specific, right? And then thirdly, a decision that areas selected adequately represent the biogeographic units to guide how much of each unit to include in the network. So for some pretty borderline jargon, scientific report lexicon there, but it's some key nuggets to pull out of this report that really speak to this representativity concept within the systematic approach. And lastly here, not to belabor that too much, but a protected area or areas within a network is considered representative of a biogeographic unit if, when appropriately managed, the areas allow the natural ecological functions that occur within the unit to proceed without significant perturbation from human activity. So this is a pretty key element here, criteria, and the process of incorporating representativity into an MPA network should be an iterative one, right? So something that's done in iterations, and one that optimizes the other network design features of EBSAs, ecologically and biologically significant areas, connectivity, replication, adequacy, and viability. So they're getting into some ecological lexicon there as well. And we get to flesh that out a little bit more here with, again, here's the title of that report, Science Guidance on How to Achieve Representativity in the Design of Marine Protected Area Networks, put out by DFO in 2012. That will come up there. And so looking at ecological functions or processes and examples of indicators. We touched on indicators a little bit earlier on in the course, but how they often serve as a very key element of designing and assessing really conservation goals, and used in so many different contexts. But having this touchstone to be able to measure, to assess, to refer back to. So, I'm going to read this out just, if anything, to be exposed to some of these really neat ecological indicators and functions. Primary productivity, chlorophyll A tests, nutrient regeneration. Jump down a little bit here. Benthic community processes, patterns of community composition. I love how that just takes us back to some of our ecology courses. Spatial complexity of benthic habitats, getting quite geographic there as well. Benthic pelagic coupling, indicators such as nutrient loading, chlorophyll level again. Correct me, of course, if I get the pronunciation wrong here, but piscivorous predation, diet composition, spatial scale of aggregation of prey populations, foraging range of predators within a season. Super neat things to get to read about how or what these biologists and ecologists and policymakers clue in on for designing and assessing and planning these conservation areas, marine protected areas. So here's a map out of that report, and pretty neat to get to see the different zones, Arctic Ocean, 9 different marine conservation areas. Here on the Pacific, 5 different ones. Of course, the proposed in the Strait of Georgia, which I think now has gone through. This was put out in 2012, and I certainly so appreciate going to some of those protected areas down here in the Gulf Islands this summer on Pender. We have some students from there who have been there as well. Just some stunning protected areas on land, and how that can extend into water with these conservation areas provides a really neat land-water interface, even increasing conservation goals and benefits. Then even in the Great Lakes, which new to me to learn about the conservation areas there, a very large one in Lake Superior. And I'm going to try to move this again if that's getting in your way there. But in the estuary and the Gulf of St. Lawrence, 10 different conservation areas there. So pretty neat to see distribution across the country there coming out of this report. And the second aspect then of this systematic approach is ecosystem/conservation analysis. And to turn more locally here to look at conservation analysis, marine conservation analysis specifically, in terms of being initiated by conservation organizations. For example, the BC Marine Conservation Analysis group, if you will. Just to jump back here. So it's this approach, this form of or aspect of the systematic approach, conservation analysis, heavily utilizing GIS analysis initiated by conservation organizations, often nonprofit organizations, non-governmental organizations, if we want to say. A whole host of these in BC working on coastal conservation. Rain Coast, of course, coming to mind, but and the biggest contribution that we want to point out here is the data, and how much this helps propel conservation, helps propel and support the establishment or the foundation for the establishment of conservation areas, of marine protected areas, rather, and the same there, I don't have to say rather, but and thereby the benefits, ecological, cultural benefits. So just a really neat aspect here, just a snapshot from the website. BC Marine Conservation Analysis ran from 2006 to 2013, a collaborative endeavor creating tools to help inform decision making for the coast. Everything from maps and data to the Marksan analysis, interactive atlas. So just speaking to this contribution of data put out there. That's a neat little example. And then to continue on here into another example of this, of an MPA approach, or what's known as the Ecologically and Biologically Significant Areas, EBSAs. And the map here of one of them from, the estuary and Gulf of St. Lawrence. It's one of the 5 large, or known as the Canadian Large Ocean Management Areas. This is from another report I can provide the link to, PDF from DFO in 2009. There's 10 different EBSAs within this LOMA, Large Ocean Management Area, the St. Lawrence, the estuary and Gulf of St. Lawrence, which is neat to see because I grew up not far from the St. Lawrence River, so it's yeah, always neat to see something from near home. And you know, at first glance, you know, granted I'm taking this image out of context here, but the different color shadings here are not the actual EBSAs. They're actually mapping out some of these different criteria, and I thought this was pretty neat just to round out more of understanding some of the science and perspectives that are put into designing and understanding some of these marine protected areas, and in this case these EBSAs. So some of these different criteria are uniqueness, characteristics of an area, of a EBSA being rare, unique, distinct, and for which alternatives do not exist. Another criteria being aggregation, with 3 subpoints here. So individuals of a species are aggregated for some part of the year. Individuals use the area for some important function in their life history, or structural property or ecological processes occur with high density. So, you know, we want to make sure that we're making marine protected areas where there's a significant enough amount of aggregation, that we're not just putting these marine protected areas when there's a diffuse population or lack of aggregation, you know, in other words. And then as well, fitness consequences. So areas where activities being undertaken make a major contribution to the fitness of the population or species present. Another big term from ecology there, fitness. As well, naturalness. Their explanation being pristine area or areas where few, if any, exotic species occur. And then lastly, resilience, areas which are or contain highly sensitive, easily perturbed, and slow to recover species. For example, areas with tree corals. And so that yeah, that was a little fleshing out the different criteria there for the EBSAs from DFO. And then, yeah, another aspect of this systematic approach to MPAs would be integrated coastal management and marine spatial planning. And got a little bit of an insight last week into some of that integrated coastal management in the documentary about the Northern Pacific Coast in BC. But just to a little bit of an overview there, a snapshot of integrated coastal management. What we're referring to is the development and implementation of a coordinated strategy to balance the allocation of environmental, social, cultural, and institutional resources to achieve conservation and sustainable multiple use of the coast. And we'll flesh this out more next week, but as well, just to provide a brief explanation of marine spatial planning, is analyzing and allocating parts of three-dimensional marine spaces to specific uses to achieve ecological, economic, social objectives that are usually specified through the political process. And yeah, we're going to get a fascinating guest speaker last week with some tools that are being quite novel tools in geovisualization that are being used for marine spatial planning. And yeah, so more to come on both of these aspects next week. But just to say that they're you know, another aspect of this systematic approach to MPAs, and really, you know, speaking to some of this continuum or spectrum that I was referring to, it can also show up very much so in the opportunistic approach to MPA, to marine protected areas. And you know, I have after the colon here special places and species, but we're seeing more and more how different tools from the systematic side of the MPA approach can be implemented on a more grassroots and local scales in more of what we might consider opportunistic approach. But really here the part about opportunistic, to set aside that grassroots or top-down planning aspect, and taking a look at how there's are often species-specific areas or very smaller scale land zones, water zones, special places, as we said in the past slide. So, for example, here in the Hecate Strait, glass sponge reefs. You see a map of some of these protected areas for the sponge reefs and some more detailed pictures of them, being an example of the opportunistic approach, but as well the Bowie Seamount off the west of Haida Gwaii. And yeah, fascinating bathymetry here, this underwater digital image, both satellite view from Google Earth there, but also some of these, bathymetric images here showing these seamounts out in, way off the coast of Haida Gwaii. And so it's another example of a very specific opportunistic marine protected area. Here's the name for this region in Haida language, and apparently it translates as supernatural being looking outward. The area has been long recognized by the Haida Nation as a special place and protected place. Memorandum of Understanding, it's known as an MOU. A lot of acronyms come up in conservation in policy work, huh? And so an MOU between the Department of Fisheries and Oceans and the Council of the Haida Nation was developed to confirm the commitment to cooperative management and planning within the Oceans Act Marine Protected Area. Underneath that, another key policy you could look up if you'd like, the Oceans Act, laying out some of this policy work for the marine protected areas. This demonstrates the shared goal of both parties to protect and conserve the Bowie Seamount for present and future generations, it says. So yeah, I see on the map there how far off of the continental shelf and how far west of Haida Gwaii that it is, and its continuation there up. Well, to go back one slide, we see how it's by no means just the Bowie Seamount and this geologic feature. Yeah, maybe somebody could inform us more about how that was formed. I mean, some sort of hot spots come to mind. So it's a similarity with different, Hawaii, for instance, but it could be a much different history, geologic explanation for that. And so, to continue on this MPA thread, in this case, discussing specifically Canada's mandate, was to 5% of Canadian oceans to be protected by 2017, and that was checked off. 10% of oceans protected by 2020. That hasn't quite been reached, but maybe somebody can fact check me on that, since we are not yet to the end of 2020. Some concern that the level of protection will dwindle to meet these requirements is a critique that's been raised in the academy and in the profession, in conservation circles. There's another graph that's supposed to come up here with that. So full protection versus partial protection, just to So marine reserves are fully protected, but there's other forms of MPAs may allow some amount of fishing or other extractive actions. And, so seasonal closures are a big question mark as well for some of these areas. So you have a little bar graph here of average fish biomass. Get myself out of the way for a marine reserve versus a fished MPA versus a fully fished area. And you can see how much that increased over those 8 years, especially in a marine reserve, and a little bit in the fished MPA, and not so in a fully fished area. So that's interesting. And outcomes of the Canadian MPAs. We need to keep in mind that's a very slow process, few and small as well. 5% of Canada's marine waters, but this percentage is getting bigger, as the couple slides back referred us to. There's limited protection in a lot of these areas, and really important to keep in mind, limited resources for management. This question of Parks Canada versus DFO. A lot of people would argue in both agencies there's limited resources. It's a lot of money, a lot of tax dollars goes to a lot of other different industries, as well as or industry kickbacks, industry subsidies, as well as other agencies. From a conservation perspective, we could make the case that Canada and basically every other country in the world would benefit a lot from more investment in our federal agencies dedicated to the management of these very important conservation areas, in this case marine protected areas, and our earth sure needs it. And to continue that, Canada still has much to figure out. The slide says, for instance here, protected area regulations for the Tarium Narillitate marine protected area. I don't know how to pronounce that correctly. Up off the north coast of Yukon and the Northwest Territories and the Mackenzie Delta. So you have a little map here of the different areas there, the marine protected area, and then in its policy, the 6th point says no person shall disturb or damage, destroy the areas, remove anything from them. And then in the following one, they have the following activities may be carried out in the areas, fishing, and goes on from there. So it's a bit of an example of how some of these conundrums can manifest even in the specific policies regulating them, policy regulations of protected areas. Highly complex and often problematic management and directives and policy formulations, which we hear come up again and again. And so, marine protector, some cautionary points here. Marine protected areas alone can't save oceans. All right, we also need to protect non-reserve populations. And also there's little evidence to support the contention that marine protected areas help coral success. So that's something to keep in mind, and some issues with current knowledge. We have a poor understanding of the actual dispersal abilities and connectivities between marine protected areas. For instance, how do you follow microscopic larvae through the ocean? How do you chart invisible currents, especially when they change throughout the year? And so to continue on that cautionary tale, it's easier to maintain diversity than to restore it. So, that point really speaks to the importance of getting the more protected areas established, right? So we have that diversity versus trying to go against the current, no pun intended, to restore that later. So what can't they protect from? obviously climate change, ocean acidification, sea temperature rise, sea level rise, right? Some much more global issues far extending outside the bounds of a marine protected area. Sedimentation, pollution, marine disease outbreaks, overly degraded systems. All right, so it's this is from read here from Cowan and Spanagle in 2009. It's the condition at which the receiving population that will determine what the level of subsidy is significant. This is a key phrase that from this paper. Basically what this means is that if the area right outside of the reserve is too degraded from overfishing or some other issue, it doesn't matter how good your reserve is if the new habitat isn't good enough to sustain any population. So, kind of speaking to this overly degraded systems that it's just certain limitations of MPAs. We can't hold a pie in the sky view that they're going to be able to restore overly degraded systems or protect from it. And then, they can't protect from conflicting goals. And that's, it's something that calls for more collaboration and dialogue, something that humanity and a lot of coastal communities need more of anyway, and something that marine protected area discussions can provide. And there's neat examples of that. We'll see some of those coming up here as well as next week. But so in terms of community-based conservation, lobster fishermen, fisher people in Maine, there's some classic examples of that. Lobster fisher communities coming together to from a very grassroots level to protect lobster fisheries. And seahorse protection in Philippines with the Project Seahorse. Included their little logo here if you want to check out that online. And then, but what I want to focus on a little bit more specifically are the octopus closures in Madagascar. Some local communities there doing some really neat work around grassroots marine protected areas. More on the opportunistic side of the spectrum, but some encapsulating or exemplifying a lot of these different elements that we've talked about here. So locally managed areas, these LMMAs, it's this example of this octopus closure. So one little snapshot if you want to go to blueventures.org and check out various different examples. But this is a picture from these Madagascar communities as well. Here, some of the more human geography side of things, getting to take a look at amongst these marine protected areas discussions. And always neat to see how people live in other areas of the world. And picture of fishing for octopus there. Fascinating. So some maps here. Obviously Madagascar off the east coast of Africa, and then we're down in as we call it, the southwest corner of Madagascar, and then really this neat map showing 25 different villages of the locally managed marine areas. And so this vertical box is about 75 kilometers, so it gives some scale there. This is coming out of Oliver et al. In 2015. We can include that article as well. And so these two areas in green being these two villages that have implemented their own closure periods to try to restore octopus populations, to let them rebound. These two different sites, Amagahitse and Nosinkara, in which these two villages have repeatedly co-implemented a periodic octopus fishery closure. And so this paper describes these different criteria, different variables that were assessed. In this case, in this graph, catch per unit effort in terms of kilogram per Fisher day. So it's neat that they're using some genderless, androgynous, or gender neutral anyway language here. Fisher day, referring to how many days a person has gone out fishing. And some of the statistics there graphed out for us with this no-ban site, these sites with no regional shutdown, and for two different seasons, right? So May through February, or February through May, or June through September, 30 days before and 30 days after, and that's how the data are separated. And it's speaking to how these closures really increased catch per unit effort, especially at these sites that with no ban, the sites with no regional shutdown. These are the two villages that there wasn't a regional ban, but they themselves implemented a village-wide closure on their village waters. And then this is super interesting as well. The x-axis might be just off your screen there, unfortunately, but village octopus fishery income and total village income 30 days before, during, and after. And this is from 2004 to 2011. Data are separated by season again, thus separating closures that occurred independently of a regional fishery shutdown and those that extended the shutdown, the ban, as during periods are not exactly 30 days. During values are scaled to per 30-day measure. Significance indicators show distinctions between a particular group and its before group comparison from linear mixed effect model. So, for those of you that really clue into some of the statistical specifics here, I'm going to include the paper for you to be able to dive into it a little bit deeper. But, some conclusions to draw from this fascinating research is that effective periodic closures lead to broader management. That's really interesting how essentially management can lead to more management, right? Some conservation goals and implementations can lead to broader management. Valandriek adopted sustainably broader range of community-based and co-management actions. Periodic temporary fisher closures targeted at rapidly growing species had positive economic benefits for low-income fishing communities. And it can be a promising option for coastal management portfolio in less developed nations. Okay, so in terms of the point there on substantially broader range of community-based and co-management actions, such actions included the formation of a locally managed marine area represented by a governing body, the Valandriek Committee, as well as the extension of periodic closure regime into mangrove habitats, mangrove forests, right? So that's awesome. The banning of destructive fishing methods, the formal gazetting, we could think of mapping really a gazette of the Valandriek LMMA, locally managed marine areas. So not just having it be mapped out by the community, but having it be defined into code, right? Into a legal code. That's what we're referring to here with the gazetting of it. Gazetting. It's pretty new to me to see gazette turned into a verb, but it's neat how these authors have done that. And finally, the founding of a community enforcement of 6 no-take marine reserves. So no-take meaning no fishing, right? So, and community enforcement of that. And what's, speaking to this last bullet point on the screen there of how this can be a promising option for coastal management portfolio in less developed nations, the authors go on to say how this pattern mirrors experiences with periodic closures in Vanuatu and Indonesia, where support for limited closure regimes also facilitated community engagement in broader management. So how this, how this can serve as a model for other developing and developed nations, right? And not that there's just one or the other, but I just think it's amazing how these sort of locally generated conservation schemes come into place, and then how they can help inspire other areas. May there be more of this in the world, and may researchers, maybe some of yourselves, go around the world that when it becomes safe to do so, and keep spreading the word, and our help right here in our backyard, or wherever your backyard, ocean yard is, right? I guess I throw that out there because we don't have to have this notion that we have to go out around the world to be able to help conservation. It sure is an appealing dream, but I don't know, maybe there's going to be more of a shift in this century, in this generation, to more localism in our conservation goals. And somewhat comforted by many of you living in different areas in me saying this, because it's not like we're all just in one place going to do that work. So to summarize, marine protected areas aim to provide numerous benefits by protecting coastal ecosystem goods and services. Touched on that, and we'll continue to next week. Ecosystem goods and services come up again and again in these discussions, and there's so many different angles to go with that. Marine protected areas can be established systematically, for example, in the National Marine Conservation Areas of Canada, or the EBSAs, or opportunistically, right, in terms of special places and species, the Bowie Seamount, or in terms of the octopus off of the coast of Madagascar there. Benefits of MPAs in Canada are compromised by lengthy establishment processes and their small size and constraints in management. And marine protected areas can't protect the oceans from all threats. We need compliance and support from people. And community-based conservation efforts are proving to be effective against overfishing. So that's a great one to end on there, how there is evidence that this works, and it's a great thing to keep in mind, that there's species out there depending on us to help out, and it's not just about humans, and let's not forget that, and all hands on deck. And thanks for cluing in again, tuning in, and I look forward to your questions or responses or insights, and take care. It's a wild one. We're in for a neat, fascinating future for marine protected areas and planet Earth. All right. Till next time.